Okay, so part A. I see a Z, so Y is equal to 58 degrees, PLT Z. Now to get X from here, I could use the C pattern or supplementary because there's a straight line. In either case, the calculation is very much the same. And like I said, C pattern, or I could say it's a supplementary angle. So that's A, C. Okay. I guess right here, call this A. A is 180 minus 180 degrees because of the supplementary angle theorem. I'll label that in there. Once I have that, I can get K. This has to be K because of ITT. So 2K plus 80 is equal to 180 because of SAT. 2K is 100. K is 50, so I subtracted 80 and then I divided by 2, so I have 50, and I'll add that into the diagram. Now to get N, well, I can use EAT. These are the opposite interior angles, so 50 minus 40 is 10 degrees because of EAT. Let's see, that leaves M. Well, we have a straight line along here, so this angle in here has to be 180 minus 105 minus 50, 25 degrees because of SAT, supplementary angle theorem, right? That way it'll add up to 180. And then M is part of that triangle. So M is equal to 180 minus this 100 minus this 25, we just figured out. So that's 55 degrees, and that's sum of the angles of a triangle theorem. Okay, so go back, go through the explanation. I started off with getting this angle here using SAT right up here, and then I got K, then N, and then found that extra angle in the triangle before I got M. Okay, E. All right, so I want to do anything that's easy first, so maybe A is equal to 81. PLT, well, I have a Z pattern. Okay, E is equal to 68 degrees. That's because I have an F pattern, so PLTF. So let me just add those in. Okay. Now, let's get B. B is 180 minus 68, which is 112 degrees. Supplementary angle theorem, because there's a straight line along here. C is equal to B because of the F pattern. Right, once I have B, this is also equal to 81 because of the PLTF pattern or opposite angle. And then finally to get D, 180 minus 81 minus 68 is 31 degrees. And that's because of the sum of the angles of a triangle theorem. And I could think of it as the little triangle or the bigger triangle. Either way, the calculation would be the same. That's E, then G. y is equal to 39 degrees. PLT Z. Z is equal to 39 degrees. PLTF, or opposite angle. W is equal to Z because of ITT, equal to Z, which is 39 degrees because of ITT. And that just leaves X. Now, X is part of, there's three parallel lines here, right? So let's just see, is there anything anywhere that I can get? Is it the same as X? Sorry, is Z or Y? No, it isn't. So there's a few different ways to go. I could go 39 degrees here because of OAT. And then X is 180 minus 39, 141 degrees, and that's PLTC pattern. It's one way to do it. There's other ways. That's G. Then I. Y is equal to 80 degrees. PLTZ pattern. If you're not seeing the Z, there it is. Okay. Now, there's two ways to go. I could get this angle first and then use the Z pattern to get X, but that seems sort of roundabout. So let's try it this way. There's a straight line there. The angles that form a straight line form supplementary angles, so they have to add up to 180, 30 degrees, supplementary angle theorem. And that leaves K. AB is equal to AC, so this length here and this length here is equal to the same length. It makes this an isosceles triangle. If this is a 90 here, this will be a 90. Okay. Let me think. Anything else? No, I guess that's good. What I'll do is suggest that we get this angle here first. I don't know, little c. So to get little c, you have to realize that this is also c here because it's isosceles, right? The overall triangle is isosceles. So 2c's plus 30 is equal to 180 because of the sum of the angles of a triangle theorem. Subtracting 30, 2c is equal to 150. And dividing by 2, c is equal to 75 degrees. 75 degrees. And then so to get z, we have 180 minus the 90 minus the 75. That's for this small triangle in the bottom. 15 degrees, and that's sum of the angle of a triangle theorem. Didn't have a parallel line in it at all. Okay, so that's the exercises for the second part of the angle relationships.